Hello everyone, today we will be learning the concepts of advanced transaction processing. In previous chapter we have already learned about what transaction is, what impact it leaves on our database, what problems can occur when these transactions are performed on any database concurrently, how those problems can be resolved using recovery and locking mechanism. These all things we have already covered in our previous chapter in lectures. Now, in this chapter, we will be learning about how transactions are being processed, how to create workflow for every transaction, and how the transaction processing monitor operates, and how it manages to deal with all the transaction errors. That all things we'll be covering under this chapter. So now let us start with our first topic, that is transaction processing monitor. The word itself depicts that it monitors something. So, in context to transaction, it monitors either a single transaction from one stage to another, and it takes care about every transaction is processed either completely or not at all. Its responsibility is also to ensure that each transaction should lead the database to its consistent state. So if any error occurs in between, then as per decided transactional workflow, it should take appropriate action and bring the database to its previous consistent state. Transaction processing monitor is basically used for two-tier, three-tier, and n-tier architectures. Also, it looks after the resources shared among application server are utilized properly or not. That is, optimum utilization should be made of resources. It also provides infrastructure for building and administering complex transaction processing system, which can handle large number of clients and multiple servers. Now let us see some duties carried out by Transaction Processing Monitor. It helps in creating user interface in simple manner. It manages clients' requests and server responses continuously and routes them appropriately over the network. It also maintains coordination of two-phase commit protocol where a transaction deals with multiple servers. Now, as we have seen in our previous topic, Transaction Processing Monitor, that it provides infrastructure for building and administering complex transactions. So now in this topic, we will be studying about various Transaction Processing Monitor architectures. Let us start with our first model, that is process per client model. In this model, every client request will be handled by single server process. It will authenticate the client and act as per the request of client. But as you know that it is handled by a single server process, so few problems occur in this kind of model. Those are, it needs huge amount of memory, means that memory for program code is shared by all the processes, but each process consumes memory for local data, and due to this operating system overhead is increased. And another problem is that CPU overhead increases as operating system divides up CPU time among processes by process of switching, that is called as multitasking. Now the second model is single server model. In this model, single server process acts as a middleware between remote clients and database files, wherein requests sent by clients are processed by server itself. Operating system of server handles user authentication and further executes the request of client. Unlike per process client model, this model does not block other clients as it is being handled under multi-threaded environment. The cost of switching is also low in this model as compared to previous model. Thus this model overcomes the problem of per process client model, but it has its own problems. As all the applications run as a single process, there is no protection among them. A problem in one application can harm other applications, but this can be resolved if each application is run as a separate process on a server. Another problem is that this kind of model is not suited for parallel or distributed databases, as server process cannot execute on multiple computers at once. So now let us start with our third model, that is many server single router model. Using this model, we can resolve the problems occurring in single server model. We can run multiple application server processes that access a common database by allowing clients to communicate with the application through a single communication process that routes the requests sent by the clients. This model supports independent server processes for multiple applications. It can also have pool of servers, any of which can handle client session. For example, client request can be routed to most lightly loaded server. Your server process can be multi-threaded. It means it can handle multiple clients concurrently. In this application server can run on parallel or distributed database and can also handle coordination among processes. Now let us move forward to next model, that is many server many router model. It has multiple processes rather than one to communicate with clients. The client communication processes interact with one or more router processes which route their requests to the appropriate server. In this, the controller process, that is, the monitor, starts up the other processes and supervises their functioning. Let us proceed further with our next topic, that is TP monitor structure or components. In this picture, you can see that client interacts with the application server through the network by sending the request for accessing the database. The application server then processes the request of client using various components and sends the response back to the client over the network. Let us now understand this all components in detail. Let us now understand the working of all these components in detail. It has queue manager in it who handles incoming messages from client. Queue can be durable, that is, it may survive even if system failure occurs. Using durable queue ensures message once received and stored in queue will be processed eventually even if system failure occurs. Once the transaction commits, the processing monitor guarantees message is eventually delivered regardless of system crash. ACID properties are thus provided even if messages are sent outside the database system. Many transaction processing monitor provide locking, logging, and recovery services to enable application servers to implement ACID properties by themselves. A TP monitor treats each subsystem within architecture as resource manager, as it provides transactional access to some set of resources. The interface between TP monitor and resource manager is defined by a set of transaction primitives such as begin transaction, abort transaction, commit transaction, and so on. Resource Manager also supplies data to application server. The Resource Manager interface is defined by the X or Open Distributed Transaction Processing Standard. TP Monitor administers server pools by adding server or removing them without interruption of the database system. It controls the scope of failure. If a server fails, TP Monitor can detect this failure, aborts the transaction in progress, and restarts the transaction again. In case of node failure, TP Monitor can migrate transaction to server or another node by rollbacking incomplete transaction. So now let us proceed with our next topic, that is transactional workflow. A workflow is an activity in which multiple tasks are executed in a coordinated way by different processing entities. The processing entity that performs the task may be a person or a software system. For example, a mailer, application program, or database management system. With the growth of networks and existence of various autonomous database systems, workflow provides a convenient way of carrying out tasks that involve multiple systems. For an example, email routing. Delivery of single mail message involves several mailer systems that receive and forward the mail message until the message reaches its destination. Now let us see a few examples related to transactional workflow, which includes tasks associated with the workflow application and their processing entities. First one is electronic mail routing that I have already discussed previously. It passes messages through various mailer systems until the message reaches its destination. Second one is loan processing. Previously, loans were processed by humans only, by manually filling up the forms. And now, digital application forms are available which are validated on filling, and further, loan officer just need to approve or reject the loan. Third one is purchase order processing, in which humans interact with application software for calculating the items purchased. The amount for those items is stored in the database. Let us now understand about the workflow of loan processing system. Here you can see in the picture that customer files loan application for a particular loan to loan officer. Loan officer further verifies the details of customer and then talks to superior officer for processing of loan. If superior officer gives the green signal for processing the loan officer further provides notification regarding acceptance of his loan application, or else loan officer will send the rejectance notification to the customer. Thus, the cycle should be in a closed loop. The workflow should be perfectly working in such a manner that customer should get some response properly regarding the status of its loan application. Nowadays, all information related to workflow is likely to be stored in digital form. Due to this, most of the tasks become automated. Here also, human interaction can be automated using electronic mail. They can communicate with each other using an electronic mail, and loan application can be filled up using application software. Now let us understand aspects of computerized workflow. Two activities need to be addressed to automate a workflow. First one is workflow specification. This includes detail of tasks associated with particular application and execution requirement needs to be defined. Second one is workflow execution to provide safety of traditional database system related to computation correctness and data integrity needs to be maintained and system should be durable. For example, it is not acceptable for a loan application to be lost or processed more than once because of a system crash. Now let us understand workflow specification in detail. Workflow specification mainly includes coordination of tasks involved in application processing. The coordination of tasks can be specified either statically or dynamically. Static specification. It includes defining the task and dependencies among them before the execution of workflow begins. The workflow must have preconditions that needs to be satisfied before the next task begins its execution. These preconditions are: first one, execution states of other tasks. That is, task Ti cannot start till task Tj is ended. For example, unless login process is finished, user authentication is done. Form filling should not be started. Second one is output values of other task. That is, task Ti can start if task Tj returns a specified value. For example, password used for logging into an application should match with the password stored in database while registering. This would allow user to complete its authentication. Third one is external variable modified by external events. That is, task Ti cannot be started before specified time. For example, in railway reservation system, Tatkal reservation booking in IRCTC starts only at its scheduled time, that is 10 a.m. every morning, neither before it nor late. Dynamic task coordination. Example for this is electronic mail routing. The next task to be scheduled for a given mail message depends on what the destination address is. That is, the mail needs to be forwarded further to how many mailer system, that is the question mark, and which intermediate routers are functioning in between them. Now let us understand failure atomicity requirements. Using ACID transactional requirement is difficult to implement for workflow applications. Workflow must satisfy some transactional properties. That is, workflow should be designed in such a manner that even if failure occurs in execution of transaction, the system must ensure that it will lead the database to its consistent state. Failure atomicity requirements are any application must be designed in such a way that it must have acceptable termination state of a workflow. Execution of workflow will terminate in a state that satisfies the failure atomicity requirements defined by the designer. Acceptable termination state can be designated as committed or aborted. Committed in sense that objective of workflow is achieved. Aborted in sense that workflow has failed to achieve its objective. Thus, in spite of failure, the workflow must lead the transaction to acceptable termination state. Now let us understand execution of workflow. It shows how execution of workflow takes place. The execution of tasks may be controlled by a human coordinator or system software, which is also called workflow management system. It consists of scheduler, task agent, and mechanism to query the state of workflow system. Scheduler acts as a program that processes workflow by submitting various tasks for execution, monitoring various events, and evaluation conditions related to intertask dependencies. Scheduler is also responsible for ensuring tasks to reach acceptable termination state. The duty of task agent is to control the execution of a task by monitoring processing entity. Further topics related to advanced transaction processing will be covered under next video lecture. Thank you.